Okay, so let's take a look at the grade 11 methods, the methods that we're going to do for the whole year. Remember, you have chapter review sheets and yearly review sheets. This is a yearly review sheet. So let's start by taking a look at the top left-hand corner, radicals. We're going to remember to use the radical laws. Remember, we're going to simplify and expand like we did from last year. We can add or subtract radicals by adding or subtracting their coefficients, multiplying and dividing, rationalizing using the conjugate, solving and checking our answers by isolating the root, squaring both sides, possibly again, and stating the restrictions. Set underneath the root greater than or equal to 0 and solve. Remember, you may have to rationalize something in that box to make it look more like something else in a different chapter, like trigonometry, for example. Okay, so down below we have quadratics, intro. We graph with the table of values. Anytime anyone ever asks you, anytime in the future, ever again, how do you graph something? You say table of values. This year, last year, the year before that, grade 4, physics, economics, etc. If you forget everything you've ever learned this year and you're in a final exam, just sit there and make tables of values. Okay, so we did transformations, taking parabolas and moving them up, down, left, right, changing their shape and moving them up and down. Off to the right, we have the formula for the vertex. Negative b over 2a for the x value, comma y. And we have vertex form, y equals a, open bracket, x minus p, close bracket squared plus q, where the vertex is p comma q. Your textbook may use h and k in place of p and q. Remember, the vertex is the opposite of what you see inside the brackets and the same as you see outside. Okay, let's take a look at solving for x-intercepts in factored form. Get it equal to 0. Factor it. Set your brackets equal to 0 separately and solve. I'm going to read that 3 times. I've read it 3 times or 5 times before. Get it equal to 0, factor it, set your factors equal to 0 separately and solve. Get it equal to 0, factor it, set your factors equal to 0 and solve. If it's not equal to 0, do whatever is necessary to get it equal to 0, then factor it and set your factors equal to 0 separately and solve. Get your x-intercepts using the zero product. I'm not sure the property name actually. Below we have factored form, like we looked at vertex form above and we saw standard form in grade 9 and 10. Then we use the square root method. Now remember, we completed the square. Ooh, I didn't mention completing the square and using graph second calc. I'm going to do that in big blue. When I was reading quadratics, I got carried away and I forgot completing the square, vertex form, finding vertex form, and using the calculator and finding all the buttons. So now again, I came from down here. Now remember, you're going to have to complete the square from one chapter to then do the square root method, unless it's already in vertex form where you don't have to. So that's the square root method where you square root both sides and don't forget about plus minus. Then we're going to use quadratic formula. Quad form, make sure that you learn how to punch in your graphing calculator, so at least at home or on tests if you're allowed, you can check your answers. So remember, there's the discriminant, which there are 3 cases. If the discriminant is positive, we have 2 x-intercepts. If the discriminant is negative, we have none, or wherever it is. And if it's equal to 0, we have exactly 1, where the parabola hits the x-intercept perfectly right there. Okay, bottom left, we have systems. We're going to find the intersections of graphs by substitution and elimination, or using your graphing calculator. Remember, y1 equals y2. Substitute the left-hand side in for y1 into your graphing calculator, the right-hand side in for y2 into your graphing calculator. Or add or subtract them together and find out where they're equal to 0. Go back and watch inequalities. Go back and watch grade 10 videos. Okay, below that, in red, let's go back to big red, is sequences. It says C formula sheet because the sequences formula sheet is the craziest thing ever. And for anyone who is paying attention right now, I'm just going to bring it up. So here it is. Whoa, excuse me. Here it is. It's on the website, but the BC curriculum tore apart sequences and series and put the addition and subtraction arithmetic, this whole top part, I don't know where it continues exactly right now, this whole part into grade 10, and geometric, this whole part down here, into grade 12 exponents. And I have yet to tear my code apart and split it up. But again, back to the grade 11 methods sheet. Down at the bottom left, sequences, see the formula sheet. There's when the review sheet for the chapter just has too much on it, I don't even know what to write here. Okay, top right in big blue, inequalities. We have one variable where we just use the number line. We still use sign analysis or graphing to help. We have two variables where we shade above or below, where we use test points, which is kind of like sign analysis. There's going to be linear and quadratic. And remember, when we do closed dots and solid lines or open dots and dotted lines. And obviously systems when graphing the systems that we talked about down below earlier. And remember, if you multiply or divide both sides by -1, change the direction of the sign. Okay, so absolute values and reciprocals were in the same chapter, and I understand your pain. So absolute values, we isolated the absolute value. We did the positive case and the negative case by distributing a positive into the absolute value and distributing a negative into the absolute value. Or we graphed it by making the y values positive. Be careful, that's a simple definition. Remembering absolute values like square roots can't equal negatives. And check your answer, check your answer, check your answer. So remember, y equals the positive case for graphing and y equals the negative case for graphing, and y equals the right-hand side. Excuse me. Y equals the left-hand side and the right-hand side, and the left-hand side is a positive case and a negative case, and the right-hand side is whatever it is, and it will probably be more than 2, so in this case 3. And we can do what's called a piecewise function, where writing the equation of the positive case and the negative case and the domain by these methods. And then we got into these interesting reciprocals where they were kind of like fractions with polynomials, which is actually called rationals a little bit later. And we talked about the restrictions, setting the denominator can't equal to 0 and solve. And we talked about domain and vertical asymptotes and invariant points and how to find them. Then we worked on rationals, fractions, the same methods from grade 8, due to the top, due to the bottom. Multiply tops, multiply bottoms, flip and multiply. This doesn't say like, when multiplying fractions, remember to multiply. It's just the method. Flip and multiply when dividing. Adding and subtracting using the lowest common denominator. Multiplying either a complex fraction, the top and the bottom by the LCD, or both sides by the LCD. Remember, due to one, due to all. Solving, stating restrictions. Now remember, the restrictions is the same restrictions from rationals or reciprocals. Set the denominator can't equal to 0 and solve, because in grade 8 we couldn't divide by 0. Can't divide by 0, and you can't square root negatives. They're the only restrictions. Come on, people. And in the bottom right hand corner we have trigonometry, and we did the ASTC graph and the unit circle and the special triangles and finding angles and different types of angles like theta STP, the one that counts, the angle from the principal axis all the way around to wherever it is, the reference angle, the tiny little angle inside the triangle, coterminal angles, angles that are the same like this, and plus 360 and plus 360, and the sine law and the cosine law, and the ambiguous case. And remember to rationalize if you can, or they tell you to. So that's methods. The methods that we're going to do all year. Use mine. Make your own. Just the practice of this helps you learn and categorize your ideas and see relationships between different sections. Don't do them at the end of the year or at the end of the chapter. Immediately when a teacher's doing notes and you're filling in their note pages, take out a separate sheet of paper and go, oh, what did we do today? You'd be amazed at how little English instructions if you simplify your methods. much more allowing you to do better in math by easily remembering more of them. So again, this is methods. Let's now take a look at remembers. So again, methods are methods, thing to do, and remembers are the things to remember when doing the methods.